Hello, I would like to welcome you to today's TechNet webcast, getting started with data mining. I would now like to introduce today's presenter, Warren Thornthwaite from Kimball Group. Warren Thornthwaite has been building decision support and data warehousing systems since 1980. Warren worked at Metaphor for 8 years, where he managed the consulting organization and implemented many major data warehouse systems. After Metaphor, Warren managed the enterprise-wide data warehouse development at Stanford University. He then co-founded InfoDynamics, a data warehouse consulting firm. Warren joined up with Microsoft Web TV to build a multi-terabyte customer-focused data warehouse before returning to consulting. Warren, I'll hand it over to you.
Thank you very much, Eric. In some ways, I think that introduction makes me sound a little old. You wouldn't think anyone had been involved in data warehousing and business intelligence for over 22 years, but I guess time passes. We also have with us on this broadcast, Joy Mundy, a member of the Kimball Group with me, and a co-author of the Microsoft Data Warehouse Toolkit with me. We both spent the last several years of our lives working on a toolkit book, which in the Kimball Group sort of vernacular is a collection of the best sort of techniques and approaches that we found to address certain problems like modeling, ETL, and things like that. The Microsoft book is a break from our history in that it is our first product-specific offering, and Joy and I are pretty excited about that. What it has allowed us to do is to take the techniques that we have pioneered and developed in detail in the Kimball Group and translate them down into the Microsoft platform to save all of you a step in having to do that yourself to make that translation. So we're pretty excited about the book. It just came out earlier this year, and this particular presentation on getting started with data mining is essentially an excerpt from that book. So Joy and I also offer classes through Kimball University, and of course Kimball University does what we call strategic consulting, and strategic of course means we charge a lot of money for it, right? That's the nature of consulting, and especially when you include fancy words like strategic. There aren't a lot of us in the Kimball Group. In fact, there are only 6. We're not here to try and get you to sign us up for lots of consulting or classes or things like that. Our real goal is to try and help people be successful in this area. There are a lot of pitfalls and a lot of challenges, and it's easy to get into trouble. So what we really try and do is help people stay on a path that's going to help them succeed. Along this vein of introduction, so you know something about me and about Kimball Group and us, I'd like to get a sense for who you all are. And this is actually a feature of live meeting that I like because it does allow you to give me some information. So if you could just, using the interface, just click on which of these sort of describes how much experience you've had with data mining, from none at all at the top to really sort of doing it in a serious way at the bottom. And let's make these results available so you all can see where people are in this process. If I can figure out the right button to push.
I just made them shown.
There. See, that's why we have professionals working with us. So this is actually really good. Most of the audience is sort of down at the less experienced end, which is great because that's what we're really talking about. How do you get started with this process? What kinds of things can you do to really make sure that you're going to solve an interesting problem and add value to the business? So that's really good. I'm going to move along to the next poll, which just gives me a sense for who you are. I'm presuming actually that you're on Data Warehouse and Business Intelligence team, and that you have some role, some specific primary role, if you will, on that team. I think you'll see that there's going to be some people who play all of the roles or many of the roles, especially in smaller organizations and smaller projects. So this is interesting. We're getting a really broad distribution across the whole, the major sort of roles, the project lead, data model, the ETL, and the front end, the business analysis and report development front end part of the process, and then of course a big chunk down in all of the above. So that's great. I'm really happy to see people from sort of representing lots of different backgrounds, and I think that's common because there really aren't a lot of us who are what I'd consider to be true data miners. In fact, let me say that I don't consider myself to be a true data miner. I'm not a statistician. I don't have that background. I'm sort of a good representative of the new generation of business person who's recognizes data mining as a useful and interesting tool that I can apply to some of the business problems I'm working with. So this is a good cross section of the population. I'm really glad to see that. And finally, I'm just interested in what the context is for your data mining effort. Sort of starting from the idea of a departmental data mart, or and then progressing up through the last choice there, the third generation enterprise says that I'm in an organization that's done this several times and is really sort of working on getting it right, if you will. So this is good. This is interesting. Let's make sure that we make these.
They're now shown.
All right. The two big spikes in our population: the departmental data marts and the first generation enterprise-wide data warehouse business intelligence system. And those are both really good places. In other words, the departmental data mart is a good place for us to start experimenting with data mining, and also the idea of the first generation is another good place for us to start experimenting. In other words, we're starting out on a new phase or a new part of this process, and we can include the data mining fairly easily. So that's great. This is really interesting stuff. I appreciate your input. So let's dive in. What are we going to cover today? I'm going to talk a little bit about, in general, how we use data mining from a business perspective. I'm going to give a brief review of the SQL Server 2005 data mining architecture and tool set, and I say brief because I don't want us to spend too much time worrying about the technology. I really want to focus on the next two items, this idea of a business-based approach to data mining, and then sort of present that or demonstrate, if you will, through a case study using the AdventureWorks data. The case study, by the way, is not going to be a demo. It just takes too long to sort of move back and forth, and we have such limited time. I will, however, and I'll repeat this later, but I will put the packages, the analysis services and integration services packages that we'll be looking at on the book's website, and the book's website is listed in the more information slides at the end of this deck. So we'll make sure that we make that available for folks to really dig into the technology and experiment if they really want to, if you really want to. So a business basic prerequisites, obviously some knowledge of SQL Server is helpful, some knowledge of or understanding of statistics and data mining is certainly helpful. If you don't have these things, you can get them. There are courses, there are books available that are very helpful to fill in some of these backgrounds. One of the things that Joy and I did at WebTV when we started doing data mining was we went out and got some expertise in statistics by going over to Stanford University and posting a job listing on the board in the statistics department. And we got ourselves a graduate student who was thrilled to be paid $18 an hour, much more than his professor was paying him, and was thrilled to have real-world data. And this it really worked out well in terms of bringing in that expertise so that we didn't hurt ourselves with the data mining tool set. So there are ways to get these skills involved in your projects, either through learning them yourselves or bringing in other experts. So let's talk about the business uses of data mining. Why are we even on this call? Why do we want to use data mining? Sounds like fun. Here's some multiple choice tests, right? This isn't a poll, so you can't really participate because it's a trick question. It's a great opportunity for us to add significant business value. The CIO told us to. It's relatively easy to do. The marketing folks are pushing us. There are lots of reasons to do this. So the question is, which of these is right? And actually, the answer, of course, is that all of them are right at some level. I like the B, which is that it's a great opportunity to add business value. I think that we should always have a concept in our minds, or a motivation or a goal in our minds of adding business value in our data warehousing and business intelligence systems. Often we run into teams where the focus is on technology, and that just ends up missing the mark 9 times out of 10. So it's a great opportunity to add business value. It's also relatively easy to do. With SQL Server 2005 and the data mining tool set, it really is, in a sense, almost dangerously easy to do data mining. You can build data models that data mining models that may or may not be helpful. So that's where the statistical expertise comes into play. So business value is really important, and I'd say business interest is really important. So if the marketing people are asking for this kind of capability, then it's really important for us, I think, to respond and to help make sure that they get the kinds of information that they're looking for, the kind of support that they're looking for. So there are good reasons to do it. I think serving business is probably the most important one. I think the next question that we just need to touch on quickly is, what is data mining? And we came up with a definition from our perspective that says data mining is a process of data exploration with the intent to find patterns or relationships that can be made useful to the organization. And we could even shorten this to say something like data mining is a process to find useful patterns and relationships, right? That's really, at its core, that's what we're trying to do. Useful is the idea of business value, right? We're trying to create something that's going to add, that's going to make a difference to the organization. If we break that down a little bit, data mining is no single technology. It really is sort of a loosely related collection of tools and algorithms and techniques and processes and so on that we sort of bring together to address a whole range of opportunities. And you can also think of data mining as a verb, where in a sense we're applying these tools to help us understand and predict behavior, identify relationships, group items, customers or products, and so on. Those are some of the major activities that we do: predicting, identifying relationships, and creating segments or groups of products or customers, things like that. So fundamentally, data mining is a process, and with a goal of finding useful relationships and patterns. What kinds of business problems can we address with data mining? Now, these descriptions of business problems actually come out of the data mining and knowledge discovery area, and they're not as business-like as I'd like, because they're data mining statistical concepts that sort of come to the surface. Like we talk about classification as one of the kinds of things we can do with data mining. Classification is, as it says here, is assigning a particular case or an observation to a predetermined discrete set. So, is this customer silver, gold, or platinum, or is this customer likely to, either a churner or a non-churner? Is this customer a buyer or a looker? But the statistics starts to sneak to the surface because it has to be discrete sets, right? If we want to look at a continuous classification, then that gets called estimation. So, I guess part of the point I'm trying to make here is it's helpful to learn the secret code, the secret language that's used in data mining. But it's also important not to get really frustrated or caught up by it. So classification and estimation are similar. Classification produces a specific set or maps to a specific set. Estimation basically gives us a probability. Like, how likely is this person to respond to this promotion? Prediction, of course, makes makes good sense based on its name. It's future-oriented. Classification or estimation, just more confusion there. But prediction is pretty straightforward. We want to know, is this person likely to churn in the future? right? Is this person likely to purchase something in the future? So it's basically applying these techniques with a forward-looking point of view. There's a subset of prediction that also involves, well, we'll get to that in a second. Sorry. Association or affinity grouping, this has other names, common names like the idea of market basket analysis, which just says here are a set of items that commonly occur together. And we can use that common occurrence, that relationship, to potentially make recommendations or identify missing items in a set and guide customers, if you will, to something that might be of interest to them. The idea of cross-sell comes into this market basket area. Clustering or segmentation is particularly powerful business use of data mining. We can, by the way, here's another term, auto-classification. In other words, we're putting customers into groups, but we don't know what those groups are ahead of time. In other words, we're asking the data mining algorithm to figure out what the interesting groups are. And often we can find out things about our customers and their behaviors that are not at all obvious from direct observation. And these can be particularly valuable from a business perspective. We can classify our customers and then create product offerings or programs that will appeal to the subsets, to those more coherent classifications that may not appeal across the customer base entirely. Anomaly detection is extremely useful in certain businesses, in certain areas of businesses. One of the most common examples of this is fraud detection, say in credit card analysis, credit card processing. It's particularly interesting to know if a certain pattern or a certain set of behaviors is typically indicative of fraudulent behavior. You've probably seen some of the ads on TV where the characters we see are speaking in voices and saying things that do not line up with how we would expect them to be based on their appearance. And that's exactly what anomaly detection is all about. And of course, description and profiling is sort of the general use of data mining in an undirected fashion to just find out more about our customers, our products, our sales, or things like that. These are some of the common business uses of data mining, and the algorithms apply to these in interesting ways, so we'll get to that. First, let's do a brief review of the SQL Server data mining architecture. These are sort of the major components of the data mining architecture. It is based in, the engine is based in analysis services and takes advantage of the analysis services OLAP engine. Basically, when you create a data mining model, the data mining engine takes the algorithms and the data that comes in here, point B, and builds the model in a cube. Now, this, I think, is actually a brilliant use of the technology, because the cube engine is extremely fast at loading data and calculating on the fly, building and creating aggregates and so on. And these, as it turns out, are the sort of the raw material that feeds the algorithm. Sort of pre-calculating the statistics and the ratios and things like that means that the data mining process can be extremely fast on the Microsoft platform. And this is great because data mining can be an extremely sort of calculation-intensive process. So it's also, by the way, an advantage of the whole idea of the SQL Server 2005 single source provider, if you will. The data mining folks can take advantage of the analysis services engine, and they don't have to create a calculation engine of their own. The data mining process, of course, takes place in the BI Studio, and there's a data mining wizard and a data mining designer environment. We'll see some screen captures of these in a bit. Once the model is created, it can be accessed in lots of different ways, basically through a web access model, SOAP kind of model, where applications, any application essentially, can get to the model by issuing a query using the data mining extensions to SQL. And we'll take a look at one of those queries and what it might look like later. Integration Services also has some data mining and preparation tasks that it can use to, for example, during the nightly load process, if we wanted to score our customers based on one of the data mining models, we can just feed it right through that process. So it's an interesting leveraging, if you will, of the architecture where we build the model analysis services and we can access it in lots of different ways through several different interfaces. Very, very, I think, clever, if you will. A couple of terms that I've already talked about, and I'll be talking about some more just to make sure we're all on an even playing field. An algorithm is basically just as it says, the programmatic technique we use to find the relationships or patterns that are in the data. And there are lots of different algorithms. We'll look at the list of algorithms that are in the Microsoft 2005 platform in a second. A model is it's the definition of the relationships that the algorithm has found, and we'll look at, and that can be as simple as if this product exists and this product exists, then this other product is likely to exist with this probability. It can be a simple rule like that. We'll look at a couple of those rules too when we get to the case study. Case and case study are different. A case is an observation. And you think of it often. It's a customer, a single customer, and the attributes that describe that customer, and perhaps some behaviors that also describe that customer as well. A collection of these observations or cases is what we call a case set. And often we use a couple of different case sets. In building a data mining model, we'll use one to train the model and another to test it, because the idiosyncrasy of the specific training set are built into the algorithm in some cases, and we want to see how well it works on a different set of data that we call the test set. So I'll show you where that might get created in the process again in the case study. We have the idea of independent and dependent variables. The dependent variable is the target. It's the one we're trying to predict. And then we usually have lots of independent variables, or variables we hope are independent, in order to that we can use in order to predict the dependent variable. So we may want to predict churn, for example, or the likelihood to churn. And so that could be the dependent variable. And the independent variables might be the number of days since the last purchase, or the number of calls to customer care in the last month, or and not necessarily or, but and. There could be several independent variables that help us determine the target variable that we're looking for. The mining structure, of course, is it's a Microsoft term for a metadata layer that sits on top of the data source view that can be used to apply some data mining specific, essentially transformations in some cases. And some of these are important for some of the algorithms, but it's easiest to think of it as a metadata layer that we can use to sort of filter and augment the data as it comes out of the data warehouse. So that's a lot in one slide. Here are some of the algorithms. I said I would mention them. I don't want to go into them in detail because I don't want us to concentrate on the underlying technologies at this point. But the point is that Microsoft has several interesting and useful algorithms in this release. Decision trees, naive Bayes, which is sort of a simplified version of decision trees, clustering, and sequence clustering, which, clustering, of course, is this idea of how do we segment our customers or products and things like that. Sequence clustering adds an additional layer of complexity by introducing an attribute that talks about an order of occurrence. So if I go to a website, I may go from one page to another, and that path might be useful or interesting to analyze in the sequence clustering. Time series is a really powerful data mining algorithm, and a pretty common one. Obviously, we're going to use it to predict things like sales over time, and what makes it stand alone as a separate algorithm is it includes several time variant factors or capabilities, like it will factor in seasonality and you know, holidays, things like that, that can have an impact on time-based activities. The association algorithm is an important one for the idea of market basket analysis. We talked about association or affinity grouping as the business use of this algorithm. And neural network is a very interesting algorithm that basically tries to mimic the way our brains work, where we have a set of inputs and they connect to a set of nodes, essentially like neurons. And each node generates an output, and ultimately the nodes come together to generate the dependent variable, an estimate for a value, you know, whatever it is we're looking for. And the network is trained by feeding the errors back on itself and minimizing those errors. In a sense, it's a black box outcome. It's very interesting and kind of fun to play with. So I don't want to talk any more about technology. Let's dive into this idea of a business approach to data mining. What we put together in the book is essentially a three-phased approach that starts out with an emphasis on business in this first phase. And in this phase, there are two major tasks. The idea of identifying business opportunities and then sort of doing some data exploration to make sure that we have appropriate data to support the goal and the business opportunities that we've identified. And by the way, data mining is an extremely iterative process, and you see a lot of arrows going back and forth in this particular process diagram. And so, and the same is true in this business phase. We may find things in the data that help us guide us better to sort of narrow down the business opportunities, or we may find business opportunities that don't necessarily have data to support them, and you know, so we end up going back and forth in this iterative process. Once we sort of reach a point where we're pretty confident in our data mining opportunity, we describe that in a document at this point here, and we review it with the business folks and make sure we're all headed in the same direction. That then takes us into the data mining phase, and this is extremely iterative. And this, by the way, is one of the powers of the SQL Server 2005 data mining environment. It allows for or supports this iteration in a really sort of straightforward fashion, so that we can explore as many different sort of alternatives as possible in the time frame allowed. There are three tasks in this phase, three primary tasks: the data preparation task, where we'll build those case sets we described, the model development task, where we'll try different algorithms and different parameters, and an evaluation task, where we sort of compare the different approaches we've taken and see which ones seem to be most effective in describing or predicting or grouping or forecasting or whatever it is we're trying to do with our data mining process. At the end of this phase, we come out with a data mining model that we feel is going to be the one that's going to be most effective. And we'll review that at this point with our business folks and with our operations folks, so that everyone understands what the model is, what its implications are from an operations perspective, what our expectation of it is from a performance perspective, how we're going to measure that performance, and so on. I mean, this is an important discussion that takes place at this point. It's particularly important depending on the nature of the model and how it's going to move out into the operations world. Some of the models we create really have a very low impact on operations. They're not. There maybe we run once a month and we score our customers, and we do that as part of the ETL process, you know, the extract, transformation, and load process for the data warehouse, and it really doesn't affect anyone else. So in that case, implementation is really pretty simple. You know, at the other end of the spectrum, it could be a model that's going to go into our transaction world, and it's going to be used as part of the user experience essentially in a near real-time fashion. If we're making recommendations, or if we're doing fraud detection, or these kinds of things, obviously they need to happen at sort of transaction speeds, and that can be a significant issue when we get into this operations world. We want to make sure we assess the impact. How did it do? Did it work as we expected? So on. There's always maintenance of models as we keep them in operation. The models themselves get stale as the data changes over time, as customer behaviors change over time. We need to make sure we keep them fresh. So there's an ongoing maintenance process. And based on our impact assessment, we're going to lead back into the business world and start another round. Now let's run through. I'm going to run through each of these. I actually did more in the drawing than I had anticipated. I'm just a little too excited about it, I guess. So in the business phase, this is sort of a review of what we said. We're going to talk with the business folks about the kinds of processes they do, and we're going to be looking for where relationships between, say, customer behaviors and their the ultimate outcomes, orders or sales or cancellation or whatever it is we're looking for. We're going to be looking for places where those relationships might exist. And in many cases, we start with the question, just sort of tell me what you do. And then it's our job to listen and try and identify some of those places where we might be able to apply some of the data mining capabilities. We're also, of course, in this phase going to look for the relevant data and make sure that it's there. We want to, while we're talking to business users, we want to understand the potential impact. Is this something that is the process itself, is it a $50,000 process or a $500 million process? And how much do we think we can improve it? If it's 1% of 50,000 is not much, 1% of 500 million says, let's pay attention here. Maybe we can do something useful. The end of this, of course, is going to be the creation of what we call the opportunity document. We want to make sure we describe what we're up to and how we think it's going to help and how we're going to go about doing it so that the business folks are on board and supportive and participative in the process. It's a good idea to keep them involved. Once we get into the data mining phase, one of the primary things, the first step, as we talked about, is creating the data sets. And I talked about training versus test data sets. We want to make sure that we have good data quality, that we're not putting garbage into the process, because data mining is particularly sensitive to bad data. The model will take bad data and treat it as if it were real, and it will give you an answer. And you may not know that the answer is fundamentally flawed. So it's really important to make sure that what we're feeding into it is good. In terms of creating these data sets, we'll generally add many calculator fields to describe behavior, like this idea of the date since the last purchase. We'll also include as many sort of descriptive elements as we can, to, any demographics we have, any registration information we have, anything we have. We'll put it in the data set. A lot of times and this probably is bad data mining, but I'll bring over everything I can through the data mining structure and then limit what I feed into a specific model and use the model to actually tell me which elements are going to be most predictive or most useful in the model itself. And that's just part of that iterative process. The modeling, creating the models, as I said, is a process of trying different algorithms, trying different parameters, and comparing the results and making sure that we get sort of the best, most predictive model we can out of that process. And that comparison, that sort of validation process at the end of this, in particular, sitting down with the business community and reviewing the results and our recommendations and making sure that it makes sense from a business perspective, making sure that people understand the model and the recommendations that it makes, reviewing our predictions based on tools like lift charts, which says how much above the baseline activity do we expect to see based on our recommendations or based on the model we create. We may even do some demonstrations on how the model would be used in production, to work with the production people on that. This whole validation step, I think, is a really important one, and one that we often we've seen get skipped in the mining process. Once we move into operations, as I said, the approach depends on whether or not it's sort of an independent scoring model that we can run, or if it's something that's going to be in the operations world. In particular, I want to make sure that we capture the baseline of whatever process we're working on, and so that we can measure its effectiveness, so we can compare before and after, essentially. And again, we're going to iterate back, and based on what we learn, we're going to go through it again. So I want to run through a case study now this uses the AdventureWorks data, and as I said, I'll publish the packages that I created to build the case sets and to build the data mining models that we're going to be looking at, so that you can go through and pick them apart at your leisure, as our friends in the UK say. Here's basically what we're going to look at over the next couple slides. We have a couple slides on meeting with the business folks, a couple slides on the data mining phase, and then a few on the production phase as well. So let's run through these together. In the case study, the idea is that we held several meetings with some of the marketing people and came out of those meetings with several opportunity areas, which I think is pretty common in my experience. One of these was to increase web sales, and the idea here was that we wanted to make essentially real-time or live product recommendations to customers, and then potentially serve pages, serve content based on customer interest and history and this recommendation model. The issue with this is that we don't have all the data available in this case study, and the infrastructure is not available yet, although it sounds like a great opportunity. So, we want to identify and describe it, and then talk about why it's not probably going to be our starting point. Another discussion we had with some of the marketing folks was the idea of improving our direct marketing efforts. AdventureWorks sends out direct mail to customers and to prospects, and it's a fairly expensive marketing process. And to the extent that we can target these offers to folks who are more likely to respond, we can send out fewer items and get a better response with those items. So we should have a better response. We should be able to send out more appealing offers, and overall just sort of increase the effectiveness of the program. The only issue here is that in the data warehouse at this point we only have sales data. And to really do promotion analysis, you want to start with the promotions data set. In other words, we sent out 400,000 direct mail pieces last month. That's in a separate database. That's not sales, right? That's just the direct mail database. So we'd want to have who did we send it to, who responded, and then ultimately who bought something. So out of those three data sets, we only have the sales data at this point to help us. So we'll have to think about what can we do to get started with what we have. A third area that came up was this idea of identifying product sales trends early on, so that the marketing people and the sales people can adjust the product mix and change marketing messages potentially to make sure that what we're offering our customers are aligning with their needs. And this, as we talked about it, it really turns out it's just a reporting issue based on existing data that we have. It's not, at this point at least, it's not a data mining model. So this really seems to be the area that we're going to be able to do something in. And we won't be able to solve the whole problem, but because we do have sales data, hopefully we can solve part of it. So the answer, the opportunity, if you will, coming out of those meetings is to start simple. Let's look at promotions that we do to customers so that we know who they are. They're in our sales database. And let's try and create a model that will help us promote products to customers that we think they're going to be particularly interested in. In other words, the idea here from a marketing sort of terminology point of view is let's do some cross-sell kinds of stuff. Here's a person, for example, who bought X, Y, and Z. Based on other people's purchase behaviors, we think they're going to be interested in product A as well. We're all probably familiar with this idea. Anyone who's been to a website, an e-commerce website, like Amazon or any of the other major websites, has been presented with an idea like people who bought this book also bought these books. So strictly based on historical sales data, we should be able to build an interesting model that will help us make these kinds of recommendations to our customers. So at this point, we would want to write it up and review it with the business and say, you know, we picked a simple place to start. Let's give it a try, and hopefully we'll get the move ahead with it. Once we do that, we'll move into the data mining phase, and we want to create the case set. And in this example, it's a pretty easy case set to create. We really only need customers and the products that those customers bought. So it's what we call a nested data set. We have one row per customer, and then we have one-to-many rows for the products that those customers bought. And there are a couple of different algorithms we might want to start with. The association algorithm is an obvious one because we're looking for association or affinity relationships, right? These products, purchase of these products is associated with purchase of these other products. We're also going to try the decision trees algorithm and see what it tells us as well, because it can create similar kinds of models. So we'll take a look at both of these and see which one might be more interesting to us. So creating the data sets, this screen capture shows using SQL Server integration services to create the data sets. And I think this is a great thing to do, by the way, because it captures the logic of the data set in the package. So you can always come back to this and run it again, or review it to see exactly how you define a particular data set. So in the iterative process, you'll probably create several of these integration services packages to create different data sets to feed into the model. The interesting thing about this one, by the way, there are 18,484 customers in the AdventureWorks database, as you see here. And we sampled using the row sampling task, the transformation task. We sampled out 1,200 rows, and then we split that into a training data set, which has 976 rows, and a test data set, which has 224 rows. As it turns out, as I learned, and I left this in here because I think it's a really good example, but in the sort of working through the models, 1,200 rows is way too small a data set for this particular business example, because we're creating more than one underlying model, more than one decision tree, for example, and I'll show you that when we get to it. And each of those has to have, we have about 50 products or so that we're looking at, and each of those has its own decision tree, and each of those has to have enough examples to be statistically significant. And 1,200 rows divided by 50 is not nearly enough. So I had to go back and change this, and basically, rather than sample 1,200 rows when I did it in a subsequent pass, I changed it to 18,000 rows and took just about all of them. The first step in the data mining process is creating the data source view, and this is just like any other data source view in creating a SQL Server 2005 business intelligence kind of solution. This one has the customer data here. You see the purchasing data and the customer attributes in a couple of other tables up here. So this is the test set on the left. This is the training set on the right. And each of these relates to the purchase data, because all of our customers, of course, bought something from us at some point. That's why they're customers. I also put in an extra set down here, which is just all of our customers, because in the particular example we're creating, we actually don't really need to segment out test and training. We may want to do it for performance purposes or something like that, but we can build a model using all of our historical customers and apply that to our historical customer base because of the nature of the association algorithm. So we create the data source view. Based on top of that, I typically use the wizard and create the mining structure. And you see it here. It's very simple. There's a customer key which groups all of the purchases, all the product purchases together for a single customer. Right? So it says the underlying assumption here is that customers buy things that they're interested in. Now, if we were really going to be clever, we would want to sort of subtract out the products that people actually returned. But we don't have that in our warehouse yet. So we're going to start with this level of a mining structure. We don't need a lot of these other attributes, even though I brought them in the data sets, because they're not. We're really using strictly product purchases to predict other product purchases in this particular model. So it's a really nice, simple model in that way. The setting up, once we have the structure in place, we can set up different specific models using different algorithms. This one I call DM Association 1, and it's using, of course, the Microsoft Association algorithm. This one I call DM DT1, and it's using the Microsoft Decision Trees. And you see down here that I've set one of the algorithms in the association model to set the item size to 7 rather than the default of 3. And what this means is how large a group of products do we want to consider in relationship to products that we might recommend. And in our customer purchases, we often have groups of products that are fairly large. So I just raised that up a bit to get a broader example of product purchases. As we see, some of the ones that are most predictive are actually smaller sets, smaller groups of products. It's interesting to sort of see these two together. So the result of the associations model is, and I've sorted it here by a number that's called importance. Now what that means, that's why we get the statisticians involved. But essentially, we can take it as meaning that the model is indicating to us that these are particularly relevant or likely predictions, if you will. And the first one here is interesting. It says that if someone has bought a tire for a mountain bike, the ML mountain tire, and if they've also bought a road bike, the Road 250, they're very likely to want to have bought or to buy a Mountain 400W bike. And in our database, in our customer history, everyone who has bought these two products has also bought a Mountain 400. And as it turns out, there are about 25 cases of this where these two products are in the purchase set, and the Mountain 400 is as well. If we look at this same model, and there's a lot of tools in the Microsoft mining model viewing tab that let us explore the model, explore the rules that it's created and the item sets, things like that. And it's really worth spending time in this and figuring out where they come from. The decision trees model, it shows data in a slightly different way, of course, because it's a decision tree. And so it can, basically what it does is it starts with a particular product. In this case, we're looking at the Mountain 400W, although unfortunately we can't see it all because I named my data set too big. So this is an argument for using very small data set names. And so this, at the root of this tree out here, is the Mountain 400W. And then each of these nodes is a particular combination of purchase behaviors. And I've selected one down here, which is, it's very dark, which indicates that it's has a high relative amount of the target. So in this case, these are the 25 cases who bought who bought Mountain 400W bikes, and 0 of these people didn't, right? So the existing cases, all 25 of them have Mountain 400 bikes. If we look down here, here's the rule. Here's the basic algorithm we can apply. And what it's saying is that if they didn't buy women's shorts, in other words, that's missing, and if they did buy a mountain tire, the ML mountain tire, and if they did buy a Road 250, then the probability that they're going to want a Mountain 400W, I didn't make the product names up, is 96.3%. Now, you might say, well, gee, isn't it really 100%? and I might say the same thing, but you know, the decision trees algorithm accounts for the possibility that we're not seeing everything, and sort of leaves some things out for us, or makes room for things to happen. But in any case, the 96% is a pretty high likelihood that if someone has these products, the ML Mountain Tire and the Road 250, that they're probably likely to be interested in the Mountain 400 as well. So we'd go through, we'd create these models, we'd iterate on them, we would explore the underlying rules and the data, and we'd make sure we understand it, talk it through with the business people, and select what we consider to be the most effective version, and then move that into operations. Now, when we say, let's look at what some of the outputs might look like. So in here, I'm using the one of the tabs in the Data Mining Studio, the Mining Model Predictor tab, and I've run some data through it. So this side over here is purchase, is customer purchase data, and so this side right here is purchase data. And I've fed that into the model, and it has given us a set of recommendations over here. So given, in this case, what it's saying is given that a customer has purchased these things, a Mountain 200 bike, a Touring 3000 bike, and a long sleeve jersey, these are some of the things we might recommend to them. And if you look at it, and this, by the way, is the association, as it says at the top, this is the association algorithm, and it gives us some pretty obvious recommendations. Well, they bought bikes, gee, they might want water bottles. And if they buy water bottles, they might want water bottle cages, right? And they're going to want a road bottle cage and a mountain bottle cage because they bought both a mountain bike and a road bike. So these are pretty, and this, by the way, Sport 100 is a helmet. These all make sense and seem pretty straightforward. They're a little disappointing because we don't make a lot of money on them, but you know, that's all right. Maybe we can, you know, you get your customers returning, you build that loyalty, and it's a good thing. So let's take a look at the decision trees recommendations. Same customer, same purchase behavior. Now we're getting a different set, quite different set of recommendations here. One of the first things that it's recommending is the fender set for the mountain bike. But it's also actually recommending two additional bikes. We have a mountain bike over here and a touring bike. And the algorithm is saying is, hey, you know, a road bike, based on support, based on other examples in the data, might be something that this person's particularly interested in. So it's a very different recommendation set, and one that, you know, exploring the differences with the business people, exploring the differences and looking at underlying algorithms, I think would be really helpful. You know, to sort of really getting a sense for which of these two is going to make the biggest difference. But it's fun to see the results. They're very different, and often, by the way, you get to the point where you just say, okay, let's try them both. Let's do one promotion using one and one using the other, and see which one, you know, makes the biggest difference. Now, what does it mean to try them? What does it mean to move this into the implementation phase? In this case, because we're talking about direct mail, we're talking about sort of bulk mailing. All we really need to do is create some DMX queries that we can run against the data and create a set of customers that are going to be appropriate for a particular promotion. And this essentially can be a manual process, and we can do it as requested. We can do it as requested, and, you know, work with the marketing folks and just make this happen. Ultimately, what we've created actually may be something that would be really pretty easy to incorporate in the website. We can feed in a product or a couple of products that someone has browsed into the model and get back some additional recommendations. Right? Here we are. People who bought these products also bought these products. Right? We actually have created something that can let us do that fairly easily at this point. The DMX query is, so these are data mining extensions, as I said. So we have a select statement, and we're pulling out the customer key in this case. And this, by the way, is essentially the query that generated the results we saw a couple slides back. So we saw the customer key and the probability so this is targeted at a specific promotion where maybe the marketing folks say, see, we want all the people who are likely to be interested in a Mountain 200 because we need to, clear out stock or something like that. So limiting this to where the model name is Mountain 200, and then down at the end, in the outer select, where you see at the top here we have select star, so we're selecting everything from our sub-select. In the outer select, we're saying where the probability is greater than or equal to 0.8. So give me the ones with a relatively high probability. And this, by the way, I basically lifted straight out of the prediction tab of sorry, I'm losing it. The data mining workbench, right? So a lot of this I'm not really an expert at, but I do know how to copy. So it's pretty straightforward to build these, actually. So let me just briefly summarize. I really believe data mining has sort of reached its zenith, if you will, in particular with the SQL Server 2005 release. It can make a huge difference in our business in terms of adding business value, and as a technology, it's really pretty easily accessible at this point. Really need to approach it with this three-phase approach: the business, working on understanding the business opportunities first, then moving into the data mining phase, and then once we have a model that we like, moving that out into the operations phase. It's important to really focus on business value and simplicity, especially when you're starting out, to really sort of prioritize and make sure we're picking a good place to start so that we have a success and we can build on that. And iteration is sort of the key to all of this. There's a lot of going back around and a lot of sort of, it's a process of successive approximations, if you will. We sort of triangulate on the best answer. And the answers themselves, of course, can be, or the models themselves, moving them into operation can be simple or complex. And that, of course, depends on the problem we've identified. So a couple of recommendations here for next steps. Learn about your business. You really have to understand how your business works from a process point of view. What do people do? How do they do it? How do they measure it? Where are the opportunities and challenges that they see? Where can we make a difference, right? We also need to learn about data mining. There's a lot of good reference material about SQL Server 2005 data mining, and the tutorials are good. We have some references in the information section coming up. And also make sure you get the right resources involved. If you're not statistical, find someone who is. Get them involved in it. Get the operations people involved. Get the business people involved. Right? This is not a go off in the corner and do something kind of thing. You really want to build a critical mass. This is just for my own information to make sure that we can provide you all with things that are helpful. So if you just quickly sort of take a look through these and identify what might be most useful or interesting to you next in this process. And I put none of the above, of course, because many folks might think that they've had enough data mining at this point. Fortunately, not that many. We've got a pre-selected audience here, right? So all of the above, okay. And then a big focus on the full demo. And there are a couple places to actually see some of these demos. There are other webcasts that have done these already. So if you want, send us a note, send me a note, and I'd be glad to refer you to those. Okay, let's proceed. And for more information, TechNet, the books we've described, please take a look at those. These links, I think, are particularly helpful. And this third one here on the website is the book's website, and that's where I'll post the packages this afternoon. This afternoon, my time, anyway. So let's take. I think we have. Well, that's about it for our time. But I think we'll take a minute or two and open up the questions. And actually, Eric, why don't I turn this back over to you?
Okay, thank you. I would like to remind everyone you can submit text questions using that Ask button. Don't forget to fill out the survey here, and as a little incentive to do that, you could win a video MP3 player by attending this webcast and submitting the evaluation. You'll be entered to win a 30 gigabyte video MP3 WMA player. This is through July this month, 2006. So I'm going to put it up to that survey and give you plenty of opportunity, to fill it out. And I'll pass it back to you to handle some of the questions in the queue at the time we have remaining.
All right, great. I noticed out of the corner of my eye that Joy was sort of rapidly answering questions along the way. I think that's really helpful. Here's a quick one we can address. The question is, how does SQL Server 2005 handle null values in the mining data set? I would actually say, I think it's different for some of the different algorithms, but I would actually want to make sure that if I can address null values ahead of time when I'm doing the data preparation, I'd like to do that because I want to make sure that I understand exactly how I'm treating nulls. In some cases, for example, we worked on a process data warehouse some time ago. It was actually involving penicillin and the manufacture of penicillin, which is very much like brewing beer, if you've ever been involved in this. There are these big vats that they put the mix in and create the penicillin. And a process data warehouse takes measurements at specific points in time. And some of the sensors were not that great, and so we would have null values essentially. And they actually weren't null; they were zero. It would fill in with a zero value. And clearly, this is not an acceptable value for for a data mining process, because the data mining algorithm will look at that and think, oh, I should set the temperature to 0 at a certain point in time in order to achieve the highest yield rate on my penicillin production. Clearly, setting the temperature to 0 is not a good idea. So I want it, and I talked about this, I really want to understand my data and make sure that I'm handling either, I may exclude these from the data set before it even goes in. I may want to make sure that I understand how, what the algorithms are going to do with it. They may use it as another value essentially, and you may not really see how it's actually handled, or it may be something that doesn't make sense. So my point is, I really want to try and manage it if I can. I'm so sorry I didn't make the poll available. I think it'll be available in the results set if you download it. So we'll try and make sure that that happens. The answer was that a large percent of folks were interested in all of the above, and then the next largest percentage were interested in a more detailed demo. Sorry about that. How do you define, here's another question. Excuse me. How do you define acceptance criteria of the model? I'm starting to lose my voice, and we're starting to run out of time, so it's working out well. So how do we define acceptance criteria of the model? It's really about the business and the business value we're trying to provide. So in the case that we went through, the goal was to increase customer sales to existing customers, essentially. And we have a baseline experience with increasing sales to existing customers, and we can put the model into operation and to see if sales increase. I mean, there's a fairly easy way to measure that. We can also sort of specifically look at responses to the promotions, to the offers that we're sending out there, and see if those individuals are actually the ones who are responding and responsible for the increases in sales. The criteria, the acceptance level would be something we'd negotiate out with the business folks that says, we really want to see a 5% or a 10%, or 2% or 1%, whatever makes sense, whatever we might expect, improvement in order to sort of justify the effort that we're going through to put this in place. So there's another question here from Dan. He says, in a perfect world, how would you present this data to end users? For example, upper management who actually is interested in data mining and wants to see it happen. I would present it in a graphical fashion, if it's at all possible. And, in other words, here's so in the example we just went through, we might be able to show percentages of customers who are likely candidates for a particular promotion and our expected or response rate, our historical response rate and an expected response rate, and to really sort of simply show how much of a difference we plan to make, or we expect our model to make in a specific case. If you take a look in sort of the decision trees, for example, if you compare decision trees with some of the other algorithms, in the comparison tab of the Data Mining Studio, you'll see a tool called a lift chart that actually gives us an example of what some of this what some of these graphical representations might look like. So definitely take a look at some of those as a good place to start. Okay, let's we're reaching the end here, and we're going to need to make room for the next webcast. So we'll take additional questions offline. The whole question log will be available as part of the download too, so you'll be able to see the full question and answer set there. And again, we really appreciate your attending today. This has been it's been a great session for us, and I hope it's been valuable for you. And we look forward to your feedback. So please definitely fill out the survey. And thank you all very much.
Ladies and gentlemen, that concludes today's TechNet webcast. Thank you for joining us. You may now disconnect from the audio portion of this conference.